Question 5, we are finding the inverse given that f of x equals 2x plus 3 over 5x minus 7. So remember, f of x is your y, so when you go to switch your x and your y, we get x equals 2y plus 3 over 5y minus 7. The steps for solving for y are the same every time it's a fraction. We're going to put x over 1, and we're going to cross multiply. So x times 5y minus 7 is 5xy minus 7x. 2y plus 3 times 1 is just 2y plus 3. Anything with a y is going to go to the same side, so subtract the 2y over. And then anything without a y is going to go to the opposite side. So I'm going to add the 7x over. So we have 5xy minus 2y equals 7x plus 3. On the left, we can now take out a GCF of y. So that left side, when we take out the y, we are left with 5x minus 2. I have not done anything to the right side, so it's still 7x plus 3. And then we are going to divide out that 5x minus 2. So the inverse is y equals 7x plus 3 over 5x minus 2. Or you can use the inverse notation. And there's your equation. Question 6. We have our three functions. So for a, we're going to start with g of 3. So going to the g equation, we are going to plug in 3. We should get 12, which we're then going to plug into the f equation. We get 48 minus 7, so 41 as our final answer. For b, we're going to start with h of 6. So 2 times 6 plus 3, we're going to get 15. And then g of 15, 15 squared. You can do 15 times 15 off to the side. 5 times 5 is 25. 5 times 1 is 5, plus that 2 is 7. We put a 0, and then 1 times 5 is 5, and 1 times 1 is 1. So add up starting on the right. 5 plus 0 is 5, 7 plus 5 is 12, and then 1 plus 1 is 2. So that's 225 plus 3, which gets me 228. For the next one, f of negative 4 is 4 times negative 4 minus 7. So negative 16 minus 7 is negative 23. And then h of negative 23 gets me negative 46 plus 3, which is negative 43. For d, h of x is just h of x. And then it's telling me to take that and plug it into g. So you're doing g of 2x plus 3. So plugging in for x, we have 2x plus 3 squared plus 3. So we're going to write the 2x plus 3 twice. Don't forget to carry down the 3. We're going to double distribute 4x squared plus 6x plus 6x plus 9. Again, carry down the plus 3. and then combine like terms. 4x squared plus 12x plus 12. For E, find x when g of x equals 7. So g of x, that's the left side. So you're going to set that equal to 7. If you have an exponent, you should set the equation equal to 0. You are less likely to forget an answer. This is dots, x plus 2, x minus 2, which then gets me -2 and +2. If you subtracted the 3 over to get 4 equals x squared and you took the square root, that's fine, just don't forget the plus minus. And then for F, find h inverse of 9. So they're telling us that x equals 9 on the inverse of h of x. So that means if inverse means switch x and y, that it's the y equaling 9 on the h of x graph. So I'm going to take that h of x, that is my y, I'm going to make that a 9, and then solve for x. So subtract the 3, divide by 2, so we get x equals 3. Number 7, find the domain and interval notation of the following. So for A, remember a radical, you are taking the inside and we say it has to be greater than or equal to 0. So solving, x plus 6, x plus 4, which gets me -6 and -4. On the number line, -6 should be on the left, -4 on the right. That did not work out. We are allowed to equal these. So solid circles. Test point, I always test 0. 0 is to the right of -4. So you are testing that section of your number line right now. So when I plug in 0, I get 24 is greater than or equal to 0, which is true. So I like that side, which means I'm going to like the other side, and I don't like the middle. So I am shading the outsides. So in interval notation, my domain is -infinity to -6. And again, from -4 to +infinity. For B, there is no radical, there is no fraction, there is no radical in a fraction. My domain is just -infinity to +infinity. For C, the fraction, remember your denominator cannot equal 0. So I need to see what numbers do make it equal 0. So this is an equation that we can solve. It is factorable. I get -2 and +2. These are the numbers that we do not want to equal. So on my number line, those are the numbers that I would be throwing out with open circles. Any other number on your number line works. So when it's just a plain old fraction, the numbers you get for the bottom are just the numbers that you're going to throw out. So now my domain, I have 3 intervals. And here is my super long domain.